Hello and welcome to the Green Voice Podcast. I'm your host, Grant Ervin from S&B USA, coming to you from the Point Park Center for Media Innovation here in downtown Pittsburgh. And we're going to talk a little bit of plants and tunnels, sewers, regionalization, all kinds of exciting things. We have Jeff Argyros.
That's good.
All right. Score for me. And Shawn McWilliams from Alcosan, the Allegheny County Sanitary Authority. Welcome, guys, to the Green Voice.
Thanks for having us.
Yeah, thanks for having us.
This is awesome. I love that Alcosan sends duos. I think this is fun. This is, plant guy, tunnel guy. Is that right? Okay. Mm-hmm.
Inside the fence, outside the fence.
Inside the fence, outside the fence.
Yeah.
I'm starting off deep already here. Like this, are you like a traveling duo? Do you guys?
Can be. Yeah.
At times.
Yeah. I can sense that. There's some camaraderie, teamwork going here.
The two programs got to work together. The tunnel sends the flow to the plant, and we treat it.
Yeah.
I guess we have put some miles on going places.
So this is part of like the traveling road show.
Exactly.
All right. I'm loving it. Jeff, Shawn, maybe just for our audience, if you guys want to start off, maybe just doing a little introduction, about yourself and kind of your career trajectory, history, what brought you to Alcosan. I'm excited to talk a couple of things, workforce and, how that all kind of comes together. We're in a lot of conversations, locally, nationally, regionally, just about construction and engineering and kind of the growing demand for folks in this space, which is something I want to touch on with you guys. Also, just to kind of educate our audience, a couple, months ago, we had Julie and Tim here that talked about the GROW program and the regionalization program. So we're also looking to dive into, learn about the plant expansion and tunneling and what that all means, and break it down for listeners a little bit. So excited to have you guys here today. Yeah. Jeff, maybe you start off, talk a little introduction for the audience. Who is Jeff?
Sure. Yeah, Jeff Argyros. I originally grew up in the D.C. area, in the Maryland suburbs. I ended up coming up to Pittsburgh for University of Pittsburgh.
Nice.
And
hail to Pitt.
Exactly, hail to Pitt. And after I graduated from there, I found a full-time job where I'd interned. And the first year of my career was really focused in environmental permitting. And really, I give a lot of credit to that because it gave me kind of a background into that a lot of people don't get to experience. And I still bring the skills that I learned that first year into what I do today. After about a year, though, I did want to get into the design side, really into the water side. That was where a job opened up. And I started working and cut my teeth doing a lot of work in rural areas, new construction.
Okay.
So that's a little bit different than what I do today, but it's helpful because as a young engineer, you get to learn something from bottom up. A lot of new sewers. And that's really basic wastewater engineering, and it's a good starting point for any young engineer. Eventually, it goes into building an entire new sewer system for a rural village in eastern Ohio, and starting to design package treatment plants. Since that was my first experience working with concrete suppliers and designing these smallish treatment plants. But that's how I cut my teeth getting into the treatment plant side. About 2016, I was on my company was selected as the plant expansion program manager at Alcosan. Okay. So that was my first dalliance with Alcosan.
Your background's in civil?
It is.
Okay.
Correct. Okay. Yeah, I have a civil engineering degree with a construction management certificate.
Okay. All from Pitt?
From Pitt.
Okay.
Yep, exactly. So in 2016, I got involved in this program, and being a local resource, I got to do all this crazy, fun, cool stuff, starting with really getting to walk through every corner of this plant. And it's 59 acres. It's a lot to walk. Some of it's above ground, some of it's below ground. I got to see everything as a local resource. And then over those next few years, helped to develop the program and the basis of design reports that have now turned into what we're doing today. Then in about 2020, during that whole COVID time, I did switch sides. I joined Alcosan from that consulting firm.
Okay.
So I've been with Alcosan since 2020, June of 2020. And we've been heavy in construction ever since, and that's what I've been doing the last 5 years, implementing what I was involved in on that planning side, and now going through design and construction of all these 9 packages and 13 projects we've got going on at the plant. And
Okay.
the goal of that is to increase our plant's max capacity from 250 million gallons per day, which is what it is today, up to 600 million gallons per day by the end of the plant expansion program.
Nice. We'll get into that in a second. Shawn, a little bit of background on you?
Yeah, sure. So, not originally from Pittsburgh either. Always been in Pennsylvania. I grew up in South Central PA in York.
Oh, okay.
Came to
York Barbell?
Yeah.
Okay. Harley Davidson?
Harley Davidson.
Okay.
Yep.
All right.
York Peppermint Patty.
York Peppermint Patties.
York International HVAC.
Let's be
You could
honest,
go on and on.
York is kind of like the unsung hero of cities in Pennsylvania. Is that fair?
It is fair, yeah.
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 There's a lot going on there that people don't recognize, I think.
Yeah. Yeah. A lot of people from there like to say also First Capital.
Yeah, that's
So,
right.
The Articles of Confederation were signed there.
That's right. Like the world could be totally different.
Yeah.
Like York, Pennsylvania could have been the epicenter of the world, much like Washington, D.C.
Yes. So I ended up coming to Western Pennsylvania for college. My first degree was in environmental science.
Where'd you go?
I went to Teal College
Teal.
up in Greenville,
Teal
Pennsylvania.
Tomcats? Okay, all right.
That's where I met my wife, where we started our family.
Nice. Big fan of Greenville.
Yeah.
My roommate in college, a bunch of friends from Greenville, Pennsylvania. So shout out to Greenville there.
Yeah, we have some friends that still live there, some college football friends that we've made through our sons.
Okay.
We think finished up that degree, came to Pittsburgh, started doing environmental service work. Did all kinds of work related to that, water quality, steel mill work, different things. After some turn of events and then traveling, I just decided I needed a change. So I took a job with a local sewer authority in the North Hills.
Okay.
Followed that path on the wastewater side, and then found an opportunity at Alcosan, where I started there in May of 2007. Doing field inspection work, environmental construction supervisor.
Okay.
I was encouraged at that point to pursue an engineering degree by our former director, Jan Oliver.
Oh, Jan, yeah.
And she was a Point Park grad.
Uh-huh.
And I started researching programs, found the program here, and spent the next 8 years doing evening and weekend classes here to complete that degree.
That's awesome.
So, yeah.
So you're a returning alumni.
Yeah.
Awesome.
So a little more circuitous route to this point than Jeff, but
Took you a while to get that chair,
yeah,
right?
Yeah. Exactly.
That's awesome. Maybe if you guys could just real brief up front, because we jumped in a little bit, maybe give, for the first-time listener, a quick overview of Alcosan. Maybe, Jeff, I'll put that on you.
Sure.
And then, Shawn, maybe if you could lean into kind of this bigger picture of the program. I think it's first of all, I mean, it's fascinating for folks who have never been, quick plug, folks who have never been on the plant tour, which you guys do in the summer, just a quick plug for that because it's amazing. Particularly if you're from here and you kind of understand like the region and how it all works, it's something to really see. But what you guys are doing is really, it's an amazing thing for the region, but also kind of an amazing engineering and construction program too. Is that fair to say? I'd say
for sure.
But Jeff, maybe give a quick overview of what is Alcosan,
Sure.
and then we'll jump into the program.
Sure. So yeah, you gave a plug to our open house, and yeah, come on out the second weekend of September. I think September 13th. That's Saturday.
Super community event.
It's a great event. A lot of people there. You can learn a lot, but really, like what Grant just said, we give those tours, and that's kind of in my experience, a once in a lifetime experience. Quick story before I get into it. I went to open house as a student at Pitt. I got extra credit in a wastewater treatment class. It was very helpful. But having those connections between Alcosan and the universities, the local schools,
that's pretty easy extra credit there.
It was nice, but it was my first experience with Alcosan. Legitimately, I mean, as a student, I didn't really know Alcosan before that day. So it was a great experience.
Who's the professor that did that?
Leonard Casson.
See, that's pretty amazing.
Yep.
Like it gives you a little teaser of what a future career could be, right?
Sure.
And it's easy extra credit.
Yeah, who knew?
Yeah, who knew?
10 years later, that's where I'd be working.
The seed was planted right there.
Yeah. But answering your question, Alcosan, who are we? I'll give a plug back to the podcast you did with Julia and Tim last year. They did a great job talking about the history of it, but just high-level overview. Alcosan, Allegheny County Sanitary Authority. Two dates stand out in my mind from the plant side. Again, Tim and Julia talked specifically about Clean Water Act, things like that. But 1959, that was when our plant first was built. 1959, and it first went into operation. Joint authority, all these municipalities teamed up, got together to create this collective authority that now today handles sewage from 83 municipalities. And so that's what it's grown into. But the history of the plant collecting all this sewage that was originally going into the river for treatment. So we built primary treatment in 1959. Okay. That was the first time that we intercepted. That's where you get the term interceptors. We intercepted the flows from going into the rivers. They come to our treatment plant.
Alcosan's like the defensive backs of civil infrastructure.
That's a good way to put it. Yeah,
okay.
Yeah, exactly. So we built primary treatment. We built our main pump station, which is a great stop on that tour I was talking about. It's been there since 1959. That in and of itself is an awesome thing to look at, and to think that they built that in 1959 and it's still standing and it looks great today. It's great to see. So 1959, that's the first year I like to think about, and then about 1970, that's when secondary treatment was added, and I believe Tim and Julia talked about that on your last episode. But that was the second phase, that biological treatment, that really increased the treatment of our plant, and it really improved the water quality, as well as introducing disinfection prior to going into the river. So. That's the background of Alcosan. It's this collection of 83 municipalities collecting that sewage, and it's all going to one communal place.
Now, you mentioned, Shawn, that you were with a organization up in the North Hills of Pittsburgh.
Yeah.
What are just give me a picture of that. Like, what are some of like the surrounding sewer treatment facilities, and why is Alcosan in the 83 municipalities? Like, there's other ones out there, but why does Alcosan work the way Alcosan does, I guess?
Yeah, sure. It's a good point. So the authority I worked with was solely collection and conveyance.
Okay.
And so they maintained the sewers. Where you get into other communities that have their own treatment facilities, they're really probably more geographically bounded, where the flow just wouldn't come to Alcosan by gravity. So they have systems that are set up, or pumping systems that divert it back to a certain area. There's some of those spread around the outskirts of the county.
Okay.
So we really service the core of the county, and most of our system, I think we have 6 pumping facilities in our conveyance system. That's it. Everything else flows by gravity into the main plant pump station.
Okay. So like location matters. It's kind of a real estate play in many cases. Has that 83 municipalities been constant from the inception, or is there ones that have kind of come and gone or added to the system over time? That's a tough question. I think
overall it's pretty constant. There were original agreements signed by the communities with Alcosan, and Alcosan pretty much takes all the flow that they send. Okay. So, without getting into too many details, I'm not sure if anyone has come or gone.
Okay, that's interesting. And then, so like 59, 70, fast forward into kind of what gets us to like where we are today, or why we're doing what we're doing as a region. So like the basic understanding is like we get a letter from the United States of America, right, that says Correct. You're in violation of the Clean Water Act. Not you specifically, Shawn and Jeff, like we're not putting it all on your shoulders, but the region is, right? And talk a little bit about from that point, like why do you get a letter like that, and what's kind of the cause going into everything, and then how have we responded?
So yeah, these certain federal laws, governances come out, and they impact authorities across the country. We're not the only ones going.
This is the Clean Water Act, right?
Yep.
So this is like around 1970s-ish that comes into play.
Yeah, and I think secondary treatment was related to that, adding that secondary treatment, even going back to then. But around the 90s, I believe, is when the first consent decree, sometime around there is when all that negotiation began. And then there have been a lot of talks over some of this stuff predates me, so I can't speak too detailed of it.
Predates all of us. Let's be clear here.
But overall, we have come to we had a consent decree assessed against us, and then the ongoing negotiations resulting from that really resulted in what is Alcosan's Clean Water Plan, and that's an agreement between us, the U.S. Department of Justice, U.S. Environmental Protection Agency, Pennsylvania Department of Environmental Protection, and then Allegheny County Health Department. Okay. So those are our partners, our dancing partners in this, and then. As a result of that, we've got a lot of milestones to hit, and we've been doing that over the last 20 years. We've done some of those initial planning, but then also starting designs, starting construction. So what we're getting to now, they've been in talks for 20 years, decades. 20 plus years. Yeah. In fact, some of the construction even predates my 5 years here, going back just 10 years.
See, I was going to say. Because of you guys, like I was going to lead into that.
No. Some of this plant expansion stuff that we talk about, it even predates me. Increasing the capacity at our main pump station. That main pump station I talked about, where all the sewage gets collected. That was one of the first projects to really be able to have the capacity to hit some of the numbers we need to hit as a part of our consent decree. Then we're still going through them. We've got a lot of boxes to check along the way over the next 10, 15, 20 years. And that is what we are going through right now. Each of these different projects that we talk about when we come on podcasts or go to our public meeting or talk to the public at all, these are different projects that all have different consent decrees, milestones assigned to them, and we are doing our best to maintain progress on them.
And just reel back a second, too, like to get the piece of the story here is like the reasoning here is that we have, so you're treating wastewater. But also we have what are called combined sewer overflows, right? Or CSOs is the acronym that's tossed around. And so basically what is a CSO? Like if you can break that down a little bit.
Yeah, sure. So the combined sewer is where we have one pipe that carries sanitary and stormwater, typically larger in diameter. So the combined sewer overflow is whenever that combined sewage leaves the system.
Okay.
And it's usually
it's outside of the pipe.
It's outside the pipe. Yep. There's typically constructed outfalls and regulating devices that keep the dry weather flow in, but once that's surpassed, then it goes out into receiving water. And a lot of this is the consent decree is driven by the change in that CSO policy from the EPA, and that's where the negotiations started. And I think that a big challenge for the regulatory agencies and Alcosan as a region is that I think they call our region fragmented. There's so many.
Who says that, Shawn?
They do.
Okay, they do. All right.
There's so many.
We always, as Pittsburghers, talk about how close we work together and hugging and loving and all that sort of stuff. And people on the outside just don't see that, do they?
They don't get it.
Okay, fair enough.
Yeah. So each municipality, and there are many of them in the region, own their collection systems and conveyance systems.
Okay.
So that was one of the challenges and one of the efforts that Julia's team's leading on regionalization is that as Alcosan can take over more facilities, we can directly control and impact and improve those systems as far as it goes with infiltration and inflow and just the general upkeep.
Okay.
So whenever we had the consent...
So just to picture that, that's like I'm up in Shaler, and the pipe system that's in Shaler Township. That's what we're talking about when we're speaking of Julia's program.
Yeah. Okay. So the guideline for regionalization was pipes 10 inches in diameter or greater, and they have more than one municipal flow in them.
Okay.
So it could be many houses, couple houses. From that point down is where we're taking over those sewers. Okay. And since they came in, Julie and Tim, the last time, I think she's now up to 51 miles of the regionalized sewers that have been taken over.
That's significant.
Yeah, it's like the old adage of dominoes, It took a long time to get to that point. Now they're starting to fall into place.
And is that just an issue of like confidence or awareness on the municipality standpoint in terms of them understands what's going on, but also just like the time that it takes to make a deal like that happen, right?
I think there's a lot that goes into that. So, I think there was probably some relationship and confidence there, getting everyone on board with the process. And then if you go back to, I think, 2014 timeframe is when we started doing condition assessments on the potential regionalized sewers.
Okay.
So there was a whole process of collecting data, analyzing the data, putting together repair reports that we issued back to the municipalities. and then there's a whole time frame of where they have to address those, or we have to come to agreements about how they'll be addressed in conjunction with turning the sewers over.
Okay.
So there's been some transformation in that program along the way.
And when we think about like the CSO issue, like what is, just for listeners, like what's the basic cause of that? Like when you just to understand, I mean, we have water, we have wastewater, we have stormwater.
Yep.
Mm-hmm.
Yeah, combined sewer. It's sanitary sewer, which is what you flush down the toilet,
Yep.
what you're putting into your shower, and then you've got your storm sewers. That's just the grates that are in your neighborhood.
Mm-hmm.
You know, the rain's going down into the gutter. When we talk combined sewer, those two sewers combine, and so when it rains, you can imagine the capacity of these pipes are overwhelmed by the amount of rain that goes in there.
Mm-hmm.
And so that's where these constructed outfalls come into play, what Shawn was talking about. Because the capacity is reached in this pipe, the water needs to go somewhere. And if we don't have these outfalls constructed, they're just going to go out onto the street. But because we have them constructed, they're going out to the river.
Okay.
And so that's where the combined sewer overflow term comes from. It's an overflow to the river.
Yeah, and I'd say from a operational perspective, our combined sewer systems function as they were designed.
Yeah.
So it's not so much a capacity issue there. They're doing what they were designed to do.
Mm-hmm.
It's just the matter that that's no longer in compliance with the policy.
Interesting.
So, the flows come to our interceptor and regulator systems. They take the dry weather flow, every day, all day. And it's just a matter of, and we take a lot of the wet weather flow too. It's just right now with the plant and what we can convey is limited, and that'll lead into where we're going with the tunnels then.
So just to play that back, you have kind of few things. You have like the changes and advancements in policy that happen, right, in terms of, what can be and should be treated. But then you also have things like growth, population growth or development growth that's happening. And then you have, because of that, alongside of it, precipitation changes too, probably, right? So like those, am I right in thinking those three things are big contributing factors to the need for the plant expansion?
So they're all contributing factors. I think the goal of Alcosan's Clean Water Plan is to optimize capture as much as possible. Whether those factors are giant variables or not, optimize it, but also maintaining an affordable path forward for our ratepayers, because Alcosan, our projects are entirely funded by ratepayers.
Right, that's right, and which is a finite kind of audience, right?
Correct.
Mm-hmm.
Yeah.
So let's dive into like the projects. Like we talked jokingly, but inside the fence, outside of the fence. So where should we start? Inside the fence?
I think inside the fence has to start.
Okay.
That's where the current is, and then the future's going outside the fence.
Okay. Inside the fence guy?
Yep. I'm the inside the fence guy.
Okay.
So, to start out, it's really...
Every time I see you, I'm going to think of that. I'm like, hey, what's up, inside the fence guy?
Thinking about those CSOs, and things are operating exactly as they were designed, like Shawn was saying. But we have all of these now consent decree things that we're working on and towards. So right now, I mentioned we have a peak capacity of about 250 million gallons per day.
Okay.
So we have different numbers throughout the next several years. We'll be getting up to 295 million gallons per day later this year. That's our first big jump, and it's exciting because we've been working on this for 5+ years.
Okay.
So that's going from 250 to 295, and then the next jump will be up to 480 by the end of next year, end of 2026, and then we'll be going up to 600 by end of 2029, 2030 timeframe, and that's really where the tunnel will come in. But focusing in on these initial ones, what's happening there? Why exactly are we doing that? Because I think it ties into what we were just talking about. Those CSOs are operating as they are, and what's meant by that is our wet well at our pump at our plant, our pump station.
The deep.
Exactly. It's
Okay.
150 feet
Don't
deep.
fall in.
Exactly.
Yeah.
You don't want to fall in there.
Okay.
It's 150 feet deep, but that is maintained at a solid elevation all the time when it's not raining. That's
Okay.
how we maintain control of the interceptors. But as rain events come in and we're seeing more flow, our pumps can't keep up with the flow that's coming in, and that's really what causes the interceptors to rise up, and it results in those CSOs.
Okay.
So not just the pump capacity, but also how all the rest of the plant operates. Each process has its own capacity. That's what we're talking about when we're talking about the plant expansion.
Okay.
Making sure that the plant different processes are going to have the capacity to hit that 295 number later this year, that 480 number towards the end of next year, and that 600 number by the end of 2029. So that's what's going on at the plant.
Talk about what you're building.
Sure. Yeah, and I wanted to ask you where you wanted to go with that, but we've got so many projects going on, and I really do recommend folks, if they're interested, check out our public meeting. It's on YouTube, because I really am able to showcase a few different things going on, the different projects. And I mentioned we've got
this is like the teaser for that.
Exactly.
Like,
we've got 9 packages. This is how it was all packaged 7 years ago, because we need to build this thing but keep our plant in operation. That's one of our biggest challenges at the plant. So we've got 9 packages. Some of those packages have sub-projects, so we've got 13 projects ongoing.
Okay.
And
this is like a project manager's dream. Right?
It is, and it is, and that's what I love about my job. I my staff are these project managers, so I'm able to see how each of these projects are working together and how they're all going to time out, and really having to keep our contractors all aligned to make sure that we're not taking this portion of the plant off and this at the same time. So we're creating this catastrophic situation. But the projects that we've got going on, I'll highlight 3 big ones that are going on at the plant right now. So the North End plant expansion, that's one of our first flagship projects of this current plant expansion phase. And that's been ongoing since about August of 2020. That's during COVID. Now, that was a difficult time for us. A lot of lessons learned. That was the same exact time I was starting to. So I'm kind of getting thrown in and learning things on the fly. But we got our feet under ourselves, and we started moving. We maintain that because it's tied to this 295 million gallon per day that we're shooting for later this year. Think about that. We were working towards 2025 in 2020, and now here we are in 2025 talking about it. It's so cool to see how this portion of the plant transformed. Because what's happening up here, I'm talking about secondary treatment. That's our North End plant expansion. We have 16 circular 140-foot diameter clarifiers currently. We're building 2 more as a part of this North End plant expansion. That'll get us up to that 295. We're also building a new final disinfection tank, a new chemical building, and a new outfall to relocate our existing outfall to this new location. And in fact, we just did that on January 16th. We did that big transition from our old outfall to our new outfall on January 16th.
So there's just still one outfall.
There is still one outfall. We've retired our legendary old outfall that's been in operation since 1959.
Legendary, and it was like the best fishing spot on the river.
It was, and so now there's a new one. So go check it out. But yes, it was a big day for us. The Ohio River was frozen. We've got some great images. Check out our public meeting because you get to see some of that. But really, that was a huge milestone for us. So we've got this new disinfection tank activated, the new outfall activated. We haven't activated those 2 new circular clarifiers yet, so that is going to be what gets us to the 295 later this year. So that's the first project to highlight. The second one is our East Headworks project. East Headworks is preliminary treatment. That's where you take out the large and the heavy stuff. It's the first process at the treatment plant. You've got screens there to say a stump gets in for some reason. You don't want that to
basketball.
Exactly. No, seriously. You'll see flattened basketballs. And
I just think of so many disappointed kids that lost the ball.
Exactly. And if they're going down into those grates, they're coming here.
They're like, oh no.
If it fits in there, it'll get there.
So we take all that stuff out, and then we have grit handling, which is you pump a bunch of air in, and all the inorganics settle out. So that's the rocks, the bricks. Get that stuff out. Preliminary treatment is all about protecting the rest of the plant, all that mechanical equipment later on. That's what the East Headworks is. We are building a second Headworks. We've already got an existing one. It didn't used to be called the West Headworks, but now it is because we've got an East Headworks. So between those 2, that'll help us also get towards that 295 and then the 480 number next year.
And then the third?
The third project is the CSO bypass and disinfection project. This one's a little bit more confusing because this is a project that occurs right between primary treatment and secondary treatment. And this is where our flow is going to split. And you were asking, we only have one outfall. Today, yes, we do. But by the end of this project, we are going to have a second one. And so what that's going to do is the first 295 million gallons per day is all going to receive secondary treatment and then disinfection and then go out the outfall at the north end. This new outfall, this CSO bypass and disinfection, we're building a channel after primary treatment. So any flow above that 295 up to this future 600, it'll go into this bypass channel. It's a CSO-related bypass channel. It'll go towards disinfection immediately. It'll get disinfected at our old disinfection tank,
Okay.
and we're going to construct a new outfall, and that'll be outfall 2.
So that's building some redundancy into the system, but also kind of helping to accommodate like these major events.
Major events, extreme events.
Interesting.
Yep. As you creep up towards that 480 and that 600, those are the more extreme events that we don't expect to happen too often, but often enough that we need to capture them.
It's kind of fascinating to hear you guys talk about this because in some regards it's a very simple, in quotes, process that has a ton of complexity to it, right?
Yeah.
Like, so you're doing simple screening, like getting rid of like, street hockey pucks and balls and everything out of it and stumps, but then you have kind of a simple flowing process to kind of get to that clean water that comes out the outfall, right?
Exactly.
But the complexity of managing something so massive, what's that like professionally, like as an engineer, just thinking about this?
It's exciting.
Okay.
I could come into work and do 10 different things every day, and that's what I love about it. I've got a great staff. I mean, there's a whole staff supporting me.
Right.
It's not just me, but we've got a great staff that's managing all these different projects. We've got consultants that are supporting us both on the design and the construction management side, and then we've got great contractors who are working to develop that local workforce. And I mean, the amount of work and the amount of money that is going into this—that's really what it's all about.
It's massive.
Yep.
I mean, but it's also like critical to the region's economic future, right?
Definitely.
I mean, I think that's the other thing that we have to think about is there's the environmental impact and benefit that goes alongside of it. There's all the kind of the challenges, but like the economic impact created by the investment driven by the ratepayer is helping to really, provide both kind of the, the opportunities in engineering construction now, but the economic future of the region going forward too.
Exactly.
What before I transition outside the fence, I'm curious, what's it been like for you, Jeff, to go from like the design side? What was it like to step inside the fence, if you will, like to be on, working from the outside and now being on the inside?
That's a tough question. Because I think the biggest thing is understanding the relationship and the role.
Okay.
Having been on that side,
To being on the owner's side.
Exactly. Now that
right?
I'm on the owner's side and having the consultant background, it's helpful just in terms of managing.
Yeah.
What you were talking
Yeah.
about. Managing
people,
in
the
a slightly different
process.
way, but also understanding what our consultants are going through.
Yep.
Being fair and reasonable in those conversations.
Yep.
I mean, it's really just. I'll equate it to just when my career starting with just going and seeing sewer being put in the ground. And someone told me in that time, every young engineer should do that to start out. Because if you start out by drafting drawings and you don't know how the simplest fittings work together, you're never going to click.
Yeah.
But getting that experience
in the field.
Exactly. And
Yeah.
so that's how I equate it to. Just having the experience in my background, it gave me another tool to work out as the owner.
That's fascinating. Shawn, just to transition over to outside of the fence.
Sure.
So we know what's happening inside now, all kind of those, I'm going to call them mechanical processes. I know it's not mechanical engineering, but like that sort of process. But now what are we doing outside of the fence now?
Yeah, sure. So I guess for a little background, it was touched on last time. So the original interceptors we have were constructed between 1955 and 59.
Okay.
There's 30 miles of deep tunnel interceptor, which were tunneled in rock about 100 feet deep, conventional mining in the day. And we have drop shafts that connect the surface sewers down to that point. And that's where the interface is between outside defense and inside defense. As Jeff mentioned, our main pump station, we hold a certain elevation for the hydraulic grade line, which translates out through the system. So that deep tunnel interceptor acts as some storage and conveyance to the plant. On top of that 30 miles, we have another 60 miles of the shallow cut interceptor, which was just traditional excavation and digging work. And all that system is broken up by drainage basin. So we have Allegheny, Ohio, Monongahela, and we have crews that go out and maintain those daily. And those will be the crews that we'll build upon whenever we bring the new system online, the tunnel system. A lot of times we'll get questioned about if we're building new tunnels, what's happening with the old system. And really like people to know that the existing infrastructure is going to stay in place and will continue to operate. That'll be our dry weather flow and some of the wet weather flow until the tunnels come on. And that's really to pick up the excess wet weather flow that's currently going to the river. That's where we're going to capture to convey more of that to the plant. The interface that we have on those two projects, the last package that Jeff has in the plant is the wet weather pump station.
Okay.
We're going to have a dewatering tunnel that'll connect the Ohio River tunnel into the wet weather pump station, and that's where the additional 120 million gallons per day comes in for the treatment process. So the overall tunnel system that's designed today and that we're working on is comprised of 3 main packages. And we talked about the region. We rely heavily on the rivers, and it's one of our big assets.
Sure.
So our current system's named around the drainage basins and the rivers, so the tunnel systems are different. We have the Ohio River Tunnel as the first one. We have to construct that to be able to convey to the plant. And then the next one we will do would be the Allegheny River Tunnel.
Okay.
It's the longest of the tunnels projects. And then the last will be Monongahela River Tunnel.
So we're ORT, ART, MRT.
Correct.
Okay.
Overall, it'll be 16.
You guys decided to keep that simple. You didn't do like a naming rights challenge or anything?
No.
Okay.
No, if it works, you just
stick with it. Yeah.
Overall, it'll be 16 and a half miles of new conveyance then with the tunnel system. I think the ORT is about 4.9 miles. We're anticipating or we're planning to build that with a tunnel boring machine construction. It'll be 18-foot finished diameter, so it's the tunnel boring machine, or TBM, will be roughly 20 to 21-foot diameter.
Wow.
For that.
That's a huge boring machine.
Yeah, it's a good size. As you get into that world and start looking around, it's nowhere near some of the transportation tunnels that you see being built internationally.
Right.
But that 18 to 20-foot range is a good range for machines, availability, things like that as well. And it lines up with what we need as far as the modeling of it to convey the flows and dealing with the surge and just the air movement and everything else that goes along with the tunnels.
Wow, that's amazing.
Yeah.
When we think about this, and then what's kind of the time frame that we're looking at for all of this? Like here we are, like, you got started in 2020, and here we are in 2025. What's this time horizon look like? Like maybe start outside of the fence.
Yeah, so for this latest phase, I want to say the preliminary planning portion of the tunnel project, I want to say we go back to 2018 timeframe.
Okay.
So around 2019, 2020, we were wrapping up that. In 2021, we brought on our tunnel program managing team to help us out with the process. And then we brought our first designer on board at the end of 21. They got started in 22. So now we're nearing the completion of the first tunnel design for ORT. We're looking to bid that project out later this year in the end of Q2. So that'll be the first project. That'll take us through 2030 on construction. And we just brought the ART designer on board at the end of last year. Okay. So we're just starting work on that.
Okay. And ORT first because that goes directly into the plant.
It does.
Yeah.
It does. Yeah. We have one large property that's key for the program that we've acquired. It's located right on the north side between the Veterans Bridge and the old Heinz plant, Chestnut Street Bridge there. We call that Access Shaft 1 or AS1 if you ever see maps.
Okay.
That is where we'll launch the ORT TBM, and it'll head down to our last outfall at 027 by the plant.
Okay.
And then from that same shaft, we'll be launching the ART TBM.
And then go the other direction.
And we'll go up along the Allegheny. And that ends up completing up by our A42 outfall, which is right at Washington Boulevard by the Highland Park Bridge and Dam. The MRT will be launching down by Streets Run area on the Mon. That's by our M42 outfall, and it'll connect into...
By the ice cream shop?
It's up a little further from there. It's right actually next to where Sandcastle is located.
Okay.
And the Glenwood Bridge there.
Gotcha.
Yeah, that tunnel will terminate into the AS1 shaft, so it's kind of like a confluence of the tunnel system right there in that shaft. And yes, there's a lot happening there, a lot of interface schedule things we have to line up on all the projects.
That's fascinating.
But all that construction is currently slated as part of our consent decree has to be completed by 2036.
By 2036. Okay, so we got like an 11-year run here of major construction and tunneling. And then what about inside the fence? Like, what does that look like from does that have to be done before the tunneling starts, or
so
can it be
the wet weather pump station, that last piece, that is a part of the plant expansion. So after the end of 2026, we'll have 2 remaining projects. We'll build one more primary sedimentation tank that'll be tied to that end of 2029 date, but then also the wet weather pump station, which is really being built to convey the tunnel flows.
Okay.
So that is the touch point between the two.
So you have to be
programs.
ready when they're done.
Correct. And we've been working very closely to make sure that we line up as closely as possible. AS1, I mean, they've got a headache up there to try to line up, but also at the plant between the wet weather pump station and the ORT being the end of those 2 contracts. They come together, potentially having 2 different contractors. We have a little bit of risk there.
Yeah.
In terms of timing. Okay.
Timing's a big one.
Just meeting up in the middle, so to speak.
Who gets there first?
Yep.
Yeah. Ideally,
You're gonna be like, Jeff, where are you? Shawn, like banging on the door.
Except we're 180 feet deep.
Yeah. Are you next door?
Right. Exactly.
Yeah. So ideally, the pump station has to be ready for the ORT. And ORT has to be able to convey flow to the pump station to make that work. So we have a lot of interaction and scheduling that we're doing now between the 2 teams to make sure that that's going to happen.
You know, from a construction process, just knowing the importance of scheduling, right? And you mentioned the boring machine. I'm wondering, one of the things, how is technology and changes and advancements in technology, both on like the equipment side, but scheduling software and all these sorts of things that are coming into the civil engineering world. How is that? Both 2 questions. One is like, how have you guys seen that change in the time that you've worked, as young engineers to kind of now? A, and then B, what do you see kind of going forward? Like, what are some, because these are, we've talked about, big concepts like gravity and topography, and there's like, I don't want to undercut like the simplicity of some things, but the complexity, and how is technology starting to interface with that? How's it? What have you seen in the change, and what do you see going forward?
Sure. Yeah, on the construction side specifically, into the scheduling software of what you're talking about. I mean, Primavera P6 is really the Cadillac right now that's being used. I took a course on that in college. I'm not an expert, though. I don't dalliance in it too much, but our construction manager absolutely has to have that skill set, have that technology, and our contractors do. At the plant, that's a challenge for us because we are under the Separations Act. So at plant jobs, when we're touching buildings, we have to have a general, electrical, an HVAC, and a plumbing contractor, and all of them have their own schedules. Now, do they all line up to hit our milestones? No, and that's where we need to lean on our CM's skill set and using a schedule to tie everyone's schedule together. So, I mean, our program wouldn't be able to operate without a P6 type of schedule. It does a lot of investigations for you. You're not having to go through hundreds, thousands of activities. The software itself can spit out conflicts and spit out where once you've actualized the activity timeframes, you can identify, well, you were 20 days late here, or you were 20 days early here. That scheduling software is crucial to really, in my opinion, dealing with some of those separations issues that can arise.
The software can help manage that.
It can. Yep.
Okay.
And that's one of the first challenges on every project.
Yep.
Getting a schedule that's acceptable to everybody, because we have an agreement with 4 separate entities. They don't have agreements with each other, and so that's really where we take their baseline schedules, we implement it into ours. But all of that schedule has to tie to the date in our agreement, and there could become some arguments on early in a project because of that. And then you can cost load a schedule too. It can really help with payment terms.
Yeah.
And so you can build that all into your work breakdown in your schedule. So if you build a schedule and you cost load it early in the project and everyone buys into it, it really helps with tracking payment. I mean, things like that. So,
which keeps people coming back.
Exactly.
Right?
Yeah. Otherwise, I mean, every month you are having a pay app submitted, and if you've got that preliminary agreement on that schedule, that cost-loaded schedule, it's very helpful. Helpful.
Interesting. What are you seeing on the equipment side, like outside the fence too?
Yeah, I think there's definitely a lot more technology, even on our daily O&M. We're instituting a lot of more progressive technology to make use of what's available. On the tunneling side, I mean, when we first started to design, I think we had provisions in there to have physical modeling done. Because of where computational fluid dynamics and CFD and other applications are, we pretty much replaced it on ORT and just modeled everything digitally through software.
We're starting to see like digital twin technology come in and things like that.
It's starting to become more prevalent. Yeah. 3D modeling, different things like that. Even from the modeling of the hydraulics and transients and dealing with surge models and all that, it's all been done digitally. And then on the equipment side, I mean, tunnel boring machines operate. You have a staffing part of it, but then largely it's based on sensors, readouts, and that type of stuff. Is you have an operator that's sitting in a little room, smaller than a closet maybe.
Operating the machine,
looking at a screen, and it's like, so there's advancements there. There's a lot of monitoring that'll be done as part of the project so that we can get data on that. Even on the TBM, tunnel boring machine side, we'll have software that'll monitor basically every process of that machine, and you'll be able to look at that real time to see what's happening. It creates a record, for use in the process and just to have.
That's amazing. Just to wrap up here, we touched upon this in different aspects, both from kind of both of your career trajectories and these kind of advancements in technologies. Any kind of thoughts and insights that you guys would offer up, both for kind of young engineers coming into the space, but also like thinking about kind of the labor and the craft side of it. Like, what are some of the roles that are needed to help build this massive regional project and the talent out there?
Sure. I think it was touched on with the previous podcast with Tim and Julia, but getting involved in professional societies and as a young engineer, it's critical. I happened to do that. I got very involved in ASCE, Younger Member Forum, right out of college. Really because
American Society of Civil Engineers.
Really because
my job is to decode acronyms.
Thanks. Yeah. I was kind of looking for people to socialize with after college. A lot of my friends from school had gone home. But then, I mean, I'm so glad that I did that, and I really try to preach that to any young engineer I see in school or just out of school. Get involved in something. We've got so many around here. ASCE. I know you guys talked about EWRI, Environmental Water Resources Institute, and then ESWP, Engineer Society of Western Pennsylvania, SAME, Society of American Military Engineers. There's so many to get involved with. You start establishing those professional connections at 22 out of college. I mean, that'll go light years, 10, 20 years into your career. As far as the trades, I mean, I recommend anybody get involved in whatever interests you, because Alcosan has a project labor agreement to utilize local unions, and all of our contractors sign the agreement, and they become part of that agreement. So they work with the local halls to staff their projects, and we've got so much going on that sometimes we're drying out the halls, and we got to fill them up. We've got so much work to do. We've got so much more work to do in the coming years. It's an exciting time to be in Pittsburgh, whatever you're doing. Being in the trade, being in the engineering side, being in the construction side.
What are some examples of some of those trades that you guys have with your labor agreement, just to give a picture of that?
Well, there's electrical, masonry, steam fitters, laborers. I mean, there's so many. I'm going to miss.
You're going to miss somebody.
I'm going to miss.
But apologies out there. But that gives a good flavor, right?
Yep.
Absolutely. And with the airport work finishing up, I mean, this between the plant jobs and the tunnel jobs, this is the next big draw. Yeah.
Now, because we're at Point Park, what's your recommendation for the next engineer coming out of Point Park?
I would say, don't discount the the water and wastewater industry.
Yeah.
There's a lot of other opportunities out there that some may think more glamorous, but we have some younger engineers on our staff as well, and it's an exciting time to be working in this field and to see what's happening and to really be able to see a project kind of from the beginning and through the end.
Yeah.
Until the next big project. I would just say, to Jeff's point, those organizations make the most of relationships that are going to help you along the way. Try to find something you really like and that you can get passionate about. And if you have a draw for environmental stuff, it's a great place to make an impact.
That's awesome. We all need clean water.
Yeah.
With that, I want to thank you guys, Jeff, Shawn. Thanks so much. It was a great conversation. Thanks for the work that you both do, and thank you for the team at Alcosan. This is just we hit on this in so many different ways, but a major contribution to our region, and thank you for that.
Yeah. Thanks for having us.
Awesome. Thank you for listening to The Green Voice. Thank you for Anthony and Wayne here at the controls, and thank you for listening in. I'm Grant Ervin from S&B USA. We will check you out at the next episode. Be well and have a great day.